Welcome to G Fun Facts Online. Imagine a single field that produces not just food but also clean energy. A field where solar panels shelter crops from scorching heat, save precious water, and provide a stable income for farmers, all while powering our communities. This isn't science fiction. It's a rapidly growing field called agrivoltaics. But combining farming and solar power isn't as simple as just putting panels in a field. It comes with a unique set of challenges, some incredible success stories, and a future that looks like something out of a sci-fi novel. Today, we're exploring the real-world complexities and the revolutionary potential of farming under the sun. Before we get to the amazing results we're seeing around the globe, it's important to understand the hurdles, because solving these challenges is where the real innovation happens. First, there are the operational logistics. Standard farm machinery is big. Solar panel supports, on the other hand, are fixed obstacles. This means tasks like tilling the soil or mechanical weeding have to be done with much greater care to avoid costly collisions, which can slow down the whole farming process. Then, there's the human element. Farmers are experts in crops and land, but with agrivoltaics, they suddenly have to become part-time power plant managers. They're now responsible for maintaining electrical infrastructure, which requires technical expertise they might not have. This can add complexity and new labor costs. The structures themselves also present a challenge. Elevated solar panels, in particular, act like big sails in the wind, making them vulnerable to extreme weather. This requires very careful engineering and can lead to higher insurance premiums. But perhaps the biggest roadblocks are invisible. Agrivoltaics is so new that it often falls into a regulatory gray area. Zoning laws and permitting processes in most places are designed for either agriculture or energy production, not both. This legal uncertainty can cause major delays and scare off investors. Government incentives are often structured for one or the other too, failing to reward the dual-use benefits. And of course, not every crop is suitable. Sun-loving staples like corn and wheat might see reduced yields, which is a major limitation. Farmers themselves can be hesitant, worried about the long-term impact on their land, the loss of farming flexibility, and whether the financial returns are truly guaranteed. Overcoming these hurdles is the key to unlocking the full potential of this technology. And it is being unlocked. Let's look at the pioneers who are turning these challenges into triumphs. Well, start in Germany, the conceptual birthplace of agrivoltaics. The Fraunhofer Institute for Solar Energy Systems has been leading the charge. Their pilot project in Hegelbach is a landmark example. During the hot, dry summer of 2018, they achieved a land use efficiency of 186%. Let that sink in. The combined output of electricity and crops was 86% higher than if they had used two separate plots of land. Potato yields under the panels actually increased by 11% and celery by 12% because the panels provided crucial shade and reduced water evaporation. Germany is also pioneering vertical agrivoltaics. The company Next to Sun installs rows of double-sided vertical panels with wide 10-meter gaps between them. This allows massive farm machinery to operate normally while producing hay, silage, pumpkins, and soy. They're even using solar canopies over apple orchards, which not only generate power, but have been shown to reduce the need for pesticides by 70% and irrigation by 50%. Now let's jump to Japan, a country where land is incredibly scarce. They've embraced what they call solar sharing, with thousands of installations across the country. In regions like Sosa City, it's revitalizing farms by giving farmers a stable new income stream from selling electricity. The sheer variety is astonishing. Japanese farmers are successfully growing over 120 different types of crops under panels, from rice and vegetables to tea and fruits. One project is growing Japanese yam, which loves the shaded, moist conditions. Another farmer even markets a hybrid citrus fruit he grows as solar bon. In France, the focus is on high-value crops, like wine grapes. The company Sunagri has developed dynamic systems where mobile solar shutters are controlled by algorithms. They track the sun and adjust the shading based on the precise needs of the vines. The results? A water demand reduction of up to 34% and grapes with higher quality, resulting in better wine. And the United States is quickly becoming a major hub for research and application. The most famous site is probably Jack's Solar Garden in Colorado, a 1.2 megawatt community solar project that doubles as the nation's largest agrivoltaic research facility. They're studying everything from vegetables and herbs to pollinator habitats and pasture for grazing animals. Speaking of animals, solar grazing with sheep is one of the most common applications in the US. It's a brilliant win-win. The sheep manage the vegetation under the panels, which reduces maintenance costs for the solar company, and the farmer gets paid for the grazing service. In the arid climate of Arizona, the water-saving benefits are profound. University research showed soil moisture was 15% higher under panels, leading to tripled yields for certain peppers and doubled yields for cherry tomatoes. These global case studies prove that agrivoltaics isn't just a theory. It's a practical, adaptable solution that's already delivering powerful results. So what's next? If what's happening now is impressive, the future of agrivoltaics is where things get truly revolutionary. We're talking about the rise of the smart farm. The next generation of these systems won't be static structures. They will be dynamic, responsive partners in the farming process. The brain of this operation will be artificial intelligence. AI and machine learning algorithms will analyze torrents of data in real time, weather forecasts, soil moisture levels, crop growth stages, even electricity market prices. Based on this data, the AI will make autonomous decisions. For example, it could tilt the panels to create more shade for crops during a sudden heat wave, or angle them to maximize energy production when grid prices are high. The nervous system of this smart farm will be a vast network of Internet of Things, or IoT, sensors. These tiny sensors spread throughout the field will constantly monitor everything: temperature, humidity, light intensity, soil nutrients. This data feed is what allows the AI to make its precise, optimized decisions. And who will do the physical work? Robots. Autonomous systems and drones are being developed specifically for agrivoltaic fields. They'll handle planting, precision irrigation, weeding, and even harvesting, navigating the unique layouts. Automated bots will also take care of cleaning the solar panels, a crucial task for maintaining peak energy performance, all without human intervention. The panels themselves are also getting a major upgrade. We're seeing huge improvements in semi-transparent solar cells, making them more viable for greenhouses. But the real breakthrough will be spectrally selective panels. These can be tuned to let the specific wavelengths of light a crop needs for photosynthesis pass right through, while converting all the other wavelengths into electricity. It's the ultimate in light efficiency. And there's an even more mind-bending technology on the horizon: solar panels that can simultaneously generate electricity and harvest water directly from the moisture in the air. For arid regions, this could be a complete game changer. All of this innovation points to a future where the line between a farm and a power plant completely disappears. These intelligent systems will offer on-demand protection against extreme weather, making farms more resilient and our food supply more secure. They will slash the water footprint of agriculture. And by maximizing both crop yields and energy revenues through smart optimization, they will make farming more economically viable than ever before. It's a move away from thinking of land use as a choice between food or energy, and toward an integrated system that produces both more sustainably and more intelligently than we ever thought possible. From the practical challenges of today to the AI-driven smart farms of tomorrow, agrivoltaics is a testament to human ingenuity. It's a complex field, but it holds incredible promise for solving some of the biggest challenges we face in food and energy security. The dual-use revolution is here, and it's growing. one smart solar farm at a time. Thanks for listening to G Fun Facts Online.